Good day, ladies and gentlemen. Welcome back to Enriched Precalculus, and today we're talking about Chapter 6, Section 1, and we're going to be verifying trigonometric identities. Okay, so before we get started, it's important to understand that this whole box that we're about to fill out is going to be a toolbox that you're going to use throughout the chapter. Okay, so we're going to constantly be referencing this and the things that are in this to help you guys as we move through the chapter. So all of these things, I will give them to you right now. But in class, if you would like anything proven to you or wonder why it's working the way it is, then please feel free to ask. I'll be happy to help you. Okay, so the first things first are reciprocal identities. Those are very simple, and you'll probably recall them. That cosecant of an angle is equal to 1 over sine of an angle. Secant of an angle is equal to 1 over cosine of an angle. And cotangent of an angle is equal to 1 over tangent of an angle. And those can also be flipped and algebraically manipulated, so we can understand that sine is now the same as 1 over cosecant. Cosine is the same as 1 over secant. And tangent is equal to 1 over cotangent. Okay, the ratio identities, there's only a couple of them, real simple. Recall that tangent is equal to sine over cosine, and its reciprocal cotangent is equal to cosine over sine. Real simple, flipping things there. Okay, one of the big ones, new ones, I'd be happy to prove to you in class is the Pythagorean identity. So the first Pythagorean identity, there's 3 of them. Sine squared plus cosine squared is always equal to 1. 1 plus secant squared is always equal to tan squared. And this is just this second one is a derivation of this one. It's a real simple, easy proof. I'll be happy to show you. Okay, we're essentially just dividing everything by sine squared. And I got some things backwards, so I'm going to go ahead and fix them. We divide everything by sine squared. We get 1 plus cotangent squared is equal to 1 over sine squared cosecant squared. And then if we take this original one and divide everything by cosine squared, we get tan squared plus 1 is equal to secant squared. Sorry about that mistake. Okay. Lastly, our symmetrical identities. Recall that the cosine of an opposite x, reflect that thing over the y-axis, you still get cosine. If you take the sine graph and reflect it over the y-axis, you'll get the opposite sine. And tangent reflected over the y-axis is equal to the opposite tan. Okay, so let's dive right into some verifying identities. Now, it's important to understand when we verify, we're only going to manipulate one side of the identity until it matches the other side. So to do this, we'll often use all these identities up here or variations of them to simplify for expressions. Okay, so our first one that we're going to try, we're looking at this, you got to pick a side. You're either going to make the left side look like the right or the right side look like the left. And basic rule of thumb is the side that looks more difficult is going to be the side that you're going to want to manipulate. So we see 1 minus sine times 1 plus sine. Those are conjugates. And we know when we multiply binomial conjugates, we get difference of squares. So 1 minus sine times 1 plus sine is going to be equal to 1 minus sine squared. And again, we don't touch the other side. Now, if we look up here, we look at this Pythagorean identity. Look, this one looks very similar to this one. In fact, if I move this sine squared up here over to the right side, I would on the right side have 1 minus sine squared. which is equal to cosine squared. So we can make that substitution. All right, it's supposed to be an alpha. And we're done. Two-step verify. This is actually equal to this because we multiplied binomial conjugates, got difference of squares, and made a Pythagorean substitution. So let's take a look at another one. So the side that looks the most difficult seems to be the left side. So this is going to be the one that I manipulate. And this right side I'm going to leave the same. And I'm going to make this left side look like secant. Okay, so first things first, I know that tangent is equal to sine over cosine. So cosine theta plus sine theta times sine theta over cosine theta should be equal to secant theta. Now, multiply these two fractions, and I'm going to end up with cosine theta plus sine squared theta over cosine theta should be equal to secant theta. Now I'm looking at this and I'm saying, okay, all I did was multiply. This is sine over 1. That's all I did. Okay. Now, looking at this, I got something plus something supposed to equal one thing. So I know I want to combine these two things to make it into one thing. Well, they're fractions. In order to add fractions and make them into one, we need to have common denominators. So the common denominator is clearly cosine. So I'm going to make this left fraction cosine squared over cosine. Notice cosine squared over cosine is the same as cosine. Now that we have common denominators, I can go over here. Cosine squared plus sine squared over cosine should somehow be equal to secant. Well, if we rewind a little bit, we go up here. Sine squared plus cosine squared, that's equal to 1. So I'm going to make that substitution. 1 over cosine should be equal to secant. All right, did it off screen there. Substitute that 1 in for sine squared plus cosine squared. And we know that 1 over cosine is the same as secant. So we have just verified our identity that this is equal to secant theta. Okay, let's keep on cruising here. Now, as we verify this identity, we're trying to verify that this left side is equal to tangent. And the left side clearly looks more difficult. So that'll be the side that I want to manipulate to try and make it look like tan. Now, it looks a little funky, but what I'm noticing right off the bat is on the top, I've got a sine in each term. And on the bottom, I've got a cosine in each term. So I'm going to go ahead and factor out a sine on top. It's going to leave me with cosine plus 1. And on the bottom, I'm going to pull out a cosine. And that's going to leave me with a 1 plus cosine. Now, cosine plus 1 and 1 plus cosine are all the same thing, so those cancel out. And we're left with sine over cosine is equal to tangent. And we know by definition, we don't have to flip to the front, we know that sine over cosine is equal to tangent. And we have just verified our identity. Okay, let's keep on moving here. So we're looking at another one. We got a left side that needs to equal side. So clearly the left side here, again, is the more difficult looking one. That'll be the side we choose to manipulate. Okay, now we're looking at it and saying, okay, look at the top. I've got binomial conjugates again. And we know that if we FOIL out binomial conjugates, we'll get difference of squares. So let's go ahead and do that. That's going to give us secant squared minus tan squared on top, all over cosecant is somehow supposed to equal sine. Well, anytime I see a squared and a squared or a squared and a 1 of anything, I'm going to start thinking Pythagorean. Pythagorean, we just FOILed. Now let's do Pythagorean. So if we go to the front and we look for a Pythagorean identity that's got both secant squared and tan squared, our eyes go here. And notice if we move the tan squared over we end up with secant squared minus tan squared is equal to 1. Secant squared minus tan squared is equal to 1. So we can go ahead and make that substitution. 1 over cosecant is equal to sine. And now we know the definition of sine is 1 over cosecant, so by reciprocal identities, we are now verified. Okay, let's take a look at our last example for the day here. So clearly our left side is the more difficult one. This is the side we're going to work on. We're looking at it and saying we got something minus something is supposed to equal one thing. So we're going to need to combine these two fractions. In order to add or subtract fractions, remember we have to have common denominators. So looking at this, we have a cosine denominator and a cosecant denominator. So the common denominator is cosine cosecant. So we're going to multiply this left fraction by cosecant over cosecant, multiplicative identity, that's just the number 1. And we're going to multiply the right fraction by cosine over cosine. Sorry for writing small there, but that says cosine over cosine. Again, the multiplicative identity, we're just multiplying by 1. So let's go ahead and do that. Cosecant times cosecant is equal to cosecant squared. And on the bottom, we have cosecant cosine. We knew we were going to have that. For this right fraction, secant times cosine. Whenever you multiply the reciprocal of something by itself, so secant and cosine are both reciprocals of each other. Whenever you multiply reciprocals, you're going to get 1. So secant times cosine is 1. And again, cosecant times cosine. And this should all eventually be equal to cotangent. So we can combine these, and we know we got cosecant squared minus 1 on top over cosecant cosine on the bottom, and it should be equal to cotangent eventually. Oh, I got something squared and a 1. Cosecant squared minus 1. That should tell us, start looking at Pythagorean. Do we have anything with cosecant squareds and 1s? We do right here. If I move this 1 over to the right side, I end up with cosecant squared minus 1 is equal to cotangent squared. So we're going to go ahead and make that substitution. So I made that substitution. Cosecant squared minus 1 is the same as cotangent squared. Now, if I'm looking at this, cosecant times cosine, that catches my eye. I got a cotangent squared. That's almost a cotangent. Cosecant is 1 over sine. Let's just do this off in the margin here. Draw a little arrow for you. Cosecant times cosine is really 1 over sine times cosine over 1, which is cosine over sine, which is cotangent. So cosecant cosine is clearly cotangent. So we end up with our cotangent squared we had on top over cotangent on the bottom. Should be equal to cotangent. And simple power properties here. Squared cancels out with the 1 on the bottom, and we're left with cotangent equals cotangent, and we are verified. Now, I'm sure that this lesson is very unfamiliar to you and maybe a little bit uncomfortable, and that's okay. Please come to class with lots of questions. I'm happy to answer, and we'll be doing lots of examples. And just rest assured that you're going to get better with practice. We just have to practice. So look forward to helping you guys out.